Good morning, everyone. Welcome to Teaching Online with SMART, which is proudly sponsored by Basic Education in South Africa, VT Africa Holdings, Fibertech, Distributors, and Vastratech. In order for you to be part and parcel of today's lesson, you have to log into www.hellosmart.com. You have to sign up as a guest, type in your class ID, which is 598751. Add your name. So today we are still going to carry on with our physical science, grade 12, term 2. We are going to pay attention to work energy theorem, vocabulary. We have chemical energy. We have energy forms, which are gravitational potential energy, kinetic energy, nuclear energy. Okay, this is the table of content that we are going to look at. That is work energy theorem. Those forms that I was talking about is kinetic energy, gravitational potential energy, and mechanical energy. What I need you to recall, that is the definition of kinetic energy, because we have done it in grade 10 and 11. Kinetic energy, that is the energy of a moving object, and then is denoted by EK, which is equals to half mv squared. The gravitational potential energy, that is the energy. Let me just show you under the forms of energy. We have gravitational potential energy, energy of an object that has on a particular height above the ground. Okay, or you have to say the energy of a body as a result of its height above the ground. And then we have chemical energy, the energy stored within a substance. In other words, if you just want to know that we have some energies there, when you burn it, you're going to see a smoke, others you can see just a fire, is where you can talk about chemical energy. Kinetic energy, I've defined it. I said is the energy of a moving object. Nuclear, that is the energy stored in an atom's nucleus and released in a nuclear fusion. Okay. If you can just look at this, this is how you write the formula of kinetic energy. Earlier I said that is an energy that you can just get in on a moving object. We have EK, E sub of K, which is equals to half mv squared. If you can just look at this, firstly, you're supposed to know the mass of a particular object. You must know how fast the object is. Okay, in order for you to get the kinetic energy, the gravitational potential energy is going to be denoted by this equation. That is, we have E sub of P, denote the gravitational potential energy. The equation is E sub of P, which is equals to mgh. If you can just look at that as well, you're supposed to know the mass of the object, the gravitational acceleration, and the height. Okay, when it comes to mechanical energy, this is the product. This is the sum of kinetic energy and the potential energy. It's denoted by capital letter E sub of capital letter M. Okay, we have done this as well in grade 10. All right, we can't just dwell much on that. We have to move fast to this example. Is the following statement true or false? The estimated kinetic energy of a tennis ball with a mass of 50 grams. 50 grams. We have the mass of the tennis ball, which is 58 grams. During a tennis match at 50 meters per second. In other words, we have the velocity And then we have to calculate the kinetic energy of a tennis ball. All right. How do you do that? Let me just write down the given information so that we can move. All right. What is it given there? Let me just write data. The given information, we have the mass of a tennis ball, which is equals to 58 grams. We have been given the velocity. The velocity there, of course, is a vector, which is equals to 56 meters per second. Okay, and what else? We want to prove whether this kinetic energy is 1.2 kilojoules. All right, let us prove that. How do we do that? We all know that EK, E sub of K is equals to half V squared. All right, if you can just look at that, we have what? We have half. What about the mass? Mass is 58. You have to convert that into kilograms. The mass is going to be measured in kilograms. You divide by, you have to divide by 1,000 there. That is 58 divided by 1,000, which is equals to 0.058 in kilograms. Okay, if we have that, you know that you are going to substitute the given information to this formula of kinetic energy. We have 0.058 multiplied by the velocity there is 56 meters per second. Here we have in kilograms. All right, let me extend my page. Let me extend my page so that we can just have a space. That is half. I can say 0.058 multiplied by, don't forget here, it's squared. It's a squared there, 56 squared, which is equals to multiply by 0.058, which is equals to 181 divided by 2, which is equals to 90 point, let me say 91, because it's 90.9. Let me say 91. This energy is going to be measured in what? In joules. Okay, if we have that, let us check up there. Let us go back and check. That is false. In other words, your answer there is number B. That is number B. Okay. Let us move. Okay. Let us, there is something went wrong here. All right. It's fine. Now let us look at the work energy theorem. Under work energy theorem, it says that the net work done on an object is equal to the change in the object's kinetic energy. In other words, we're just going to have a work done. That work done is supposed to have, let us go back. Let me just show you this. All right. This net, we were talking about work done before. Now we have to look at the theorem. In other words, that's the combination of work and energy. We know that we have kinetic energy, we have potential energy, now we have work. Now they have to be combined to give us this theorem. In other words, the net work done. Because of that, we have done the positive and negative. Under positive, we know that the system is going to increase. When it comes to negative, the system is going to decrease as it goes along. Now we have to look at this formula. Because of that, that is the change that I'm talking about. If you can just look at this, I said it's equals to the change. Change is very, very much important. What is happening there is either you lose the energy or you can just maintain the energy. What is happening there? Under negative work done, you are going to lose the energy. But under the positive one is where you can just have a lot of energy. You have kinetic energy. The object will keep on moving. All right. When it comes to kinetic energy, that is why we have objects kinetic energy. I need you to go back to the formula where we have W net is equals to change in EK, where W net is the net work done on the object and is going to be measured in joules. What about the change in EK? That is the change in kinetic energy of an object, where you can just have the initial, the change that we talk about. Let me show you this. If you can just look at this, this is the change of kinetic energy, where it's equals to the final kinetic energy final minus kinetic energy initial. If you can just look at these two, it's where you can just find the difference. That is why we have the change in K. In order for you to define it, you must know that you have the work net. The net work done. The net work done is equal to the change in kinetic energy. Is equal to the change in the object's kinetic energy. This is the simplest. In the exam, they can ask you about this theorem. You must state it. As long as you know the formula, at the end of each and every question paper, we have the formula sheet. You have to look at it. You're not supposed to memorize it. You just look at this, okay, we're talking about the net work done. If we have a net work done, this object is equals to have the change. We have a change on that particular object that is moving, whether it's horizontal or is inclined. We don't care as long as we are going to look at the change. Okay, at the beginning, you're going to have the initial velocity. At the end, you're going to have the final velocity. I don't want to dwell much on the velocities because we have done this in grade 10 and grade 11. Okay, if you can just look at this, and this energy here, change in energy, is going to be measured in what? In joules. Okay, from the work energy theorem, we have found that every net from positive, we have what? You have to think about the increase in the kinetic energy of the object. Okay, what about the negative work done on an object? This one is responsible to the decrease. In other words, the net negative work done on an object will be equals to the decrease in the kinetic energy of an object. I need you to bear this in mind. This is very, very much important. The moment you see the negative work done, you're going to have what? A decrease in the system. But when you see the net positive work done, you're going to see the increase in the system. Don't forget that. This formula, we are going to use it quite often. I need you to familiarize yourself with this formula, because this formula is the one that is going to tell us what to do. Because they can say, calculate the velocity using the work energy theorem, calculate the net force using the work energy theorem, and so forth. All right. Okay, let us look at this example. We have Marvin's wife has gone into labor. He rushes to get his wife to the hospital in his car, which has a mass of 900. In other words, we have given the mass of the car, which is 900, and then he accelerates to a speed of 20 meters per second. In other words, we have initial velocity. The initial velocity there is equals to 0. Before it moves, we all know that the initial velocity is equals to 0. But the moment it accelerates, the moment you see accelerates, in other words, is going to the final. All right, he accelerates to a speed of 20 meters per second. Now we have in 50 meters. If you can just look at that, we have 50 meters. These 50 meters, that is the distance covered. All right, let us look at this. Use the work energy theorem. In other words, like I said earlier, we are still going to use the work energy theorem. That formula, W net is equals to change in E sub of K. All right, let me say this is very, very much important. Now they're telling us which formula or which theorem you're supposed to use. Okay, to calculate the force by the car engine to achieve the acceleration. Okay, I told you all the time that you have to write down, just have your own data, write down the given information so that you can just, this given information is going to lead you to what are they looking for. If you can just look at the work energy theorem, the work energy theorem is only the formula. But what is needed there? That is the force. We all know that the work, it has a force and a displacement. All right, let me write down the given information. Let us work together. Let us work together. Don't just copy. I need you to work with me. We have data. The given information, what do we have there? We have the mass. The mass there, which is equals to 900 in kilograms. And what else? And what else? We have initial velocity, which is equals to 0 in meters per second. Okay, and what else? We have the final, which is equals to 20 meters per second. Okay, what else? What else? We have change in x. Let me extend my page so that we can have enough space. That is change in x or s, that is displacement, which is equals to 50 meters. Okay, if you can just look at that, and what else? We have been given that this force is what they're looking for, and then we have to go back. We have been told what to do. Use the work energy theorem, which is equals to change in E sub of K. Then F net is not given. We are calculating. Is that clear? This F net is our focus. All right, let us look at that. We have the formula, W net is equals to change in EK. Okay, let us go back. Extended it. W net, we all know that work is equals to the force. In other words, we have F net. change in x cos theta. Because it's horizontal, we are going to have what? That is change in kinetic energy. That is the half. The formula there is half mv final squared minus half mv initial squared. Don't forget to put a half of an arrow on top of v to emphasize this is a vector. Okay. Let us look at this. What is it given? Do we have F net? We don't have. Do we have displacement? Yes, we have. What about the theta? Yes, we have. Is 0 degree. And then we have the mass. Yes. We have the final. Yes. We have initial velocity. Yes. Okay, what we are going to do is to substitute the given information. Before we get there, let us make the F net to be the subject of the formula. Okay. Let me choose another, that is F. That is F net, which is equals to half mv final squared minus half mv initial squared. If you can look at that, I just copied as it is, and then you have to divide by change in x cos theta. I didn't do anything. What we are going to do now is to substitute the given information in this formula. Okay, F net is equals to, then we have to say this is equals to half. What about the mass? Mass is given. Let me go back. The mass is 900. That is 900 in kilograms. And then what about the final, the velocity there is 20 meters per second. It's 20 meters per second. Don't forget that. You have to square it. All right. And what else? Minus. Okay, let me just substitute, but that is everything there is 0. It's 900 multiplied by 0 squared divided by change in x there. We have what? We have 50. This is 50 in meters. Don't forget that. Multiply by cos. What do we have there? We have theta is 0 degree. Okay. Which is equals to, all right. Let us do calculations. I need you to use your calculator. Like I said earlier, you have to use the same calculator that you're going to use in your exam. Okay. We have 900. Two, which is 180,000 minus 0. Minus 0, and then we have divided by, that is 50. Let me do it like this, multiply by 1, because 0 is equals to 1. Okay, which is equals to 180,000 divided by 50, which is equals to 3,600. Okay, this is your force, a net force. This is your net force in what? In newtons. What I need you to do, you have to double check. You have to double check all the time. The mass is 900, correct? And then the velocity is 20. And then change in x, which is 50 cos 0. And then we have 3,600 Newton. Okay. I think you have used your calculator to reach where I reached or get what I got there. Now, let us look at this example again. We have example 2. Like I said earlier, I need you to write down the given information. It's very, very much important as it is, and try to analyze each and every weight. If you come across with the acceleration, you must know that we are talking about the final velocity. If the car is at rest or anyone just standing, you must know that the initial velocity there is equals to 0. This is very, very much important. And then they will guide you. Which formula are you going to use? All the time they will tell you. Sometimes they can just say, state work energy theorem. You must know that we have the formula sheet at the back. Make sure that you go through you copy as it is. Don't do mistakes. Copy as it is, then you can define it using that so that you can memorize. All right, let us look at this example. A 600 kilogram roller coaster car, including passenger mass, is moving horizontally at the speed of 20 meters per second. Okay, the hydraulic braking system applies an external force to slow the car to a speed of 5 meters per second. If you can just look at this roller coaster is just moving with what? With 20. With what? With this 20 meters per second. Okay. Now we have what? We have this brakes has been applied to that particular car. And then it reduces the speed from 20 to 5. In other words, this is the initial velocity. This 5 is final velocity. And of course, if you can look at it, we have a negative work done. It's not positive because we moved from higher value to low. In other words, we lost energy. We lost energy. Okay, I need you to look at this. The mass is 600, and then the initial velocity is 20, and then the final velocity is 5 over a distance. Now we have been given also this distance. The distance there is 20 meters. Okay, if it's 20 meters, we know that this is the given information. What are they looking for? Determine the force. Determine the force that acts on the car. That acts on the car. All right. All the time, you have to write down the given information. You go back, you write your data. This is the given information. This given information here, what is it given? We have the mass. The mass there is 600 in kilograms. The initial velocity, which is equal to 20 meters per second. And what else? we have the final. We have the final, V final, which is equals to 5 meters per second. Okay. A distance there, let me extend my page. A distance there, that is change in x, which is equals to, you can use change in x or s. We know that that is the displacement or distance covered. All right. If you can just look at that, we have what? We have 20. This is 20 meters. This is 20 meters. Okay. Let me extend it. Let me extend it. Okay. What is it needed there? That is force. F net is unknown. Okay. If we have this, did they tell us that we're supposed to use the work energy theorem? No, but we can use it. We can use it because of the initial and the final. Okay, and distance is there. What is left there? We don't have external force. All right, they are saying calculate the force that acts on the car. All right, let us go back to the formula of work energy theorem. Okay, if you can just look at it, it's W net, which is equals to change in kinetic energy. All right. Let me extend it. All right. What is it needed there? That is the force. We all know that the formula of work is equals to the product of the force and the distance. All right. Now we have to look at this. F net. Don't forget all the time, because the force, that is change in x cos theta, which is equals to half mv final squared minus half mv initial squared. Okay, if you can look at that, we have to substitute now. Before we get there, we have to make this F net. Let me check. What are they looking for? Determine the force that acts on the car. In other words, we have to make the force to be the subject of the formula. Okay. F net, which is equals to half mv final squared minus half mv initial squared divided by change in x cos theta. All right, if you can go back there, your theta here, let me just say your theta is equals to 0 degrees. Okay. Let us look at this. What I need you to do, this time we are going to substitute whatever that you have as a given information to this formula. Okay, let us carry on. We have half the mass. This is very, very much important. Make sure that you are using the given mass. That is 600 in kilograms, multiplied by the final velocity. The final velocity there is 5 meters per second. That is 5. You have to say squared. Minus half. The mass there is 600. The mass there is 600. Don't forget that. The mass is 600. What about the initial velocity? The initial velocity there is 20 meters per second, which is 20 squared divided by. What about the distance? The distance that we had is 20 meters multiplied by cos. Your theta there is 0 degrees. Okay, we ignore the vertical. We're dealing with the horizontal all the time, whether it's vertical or horizontal. Make sure that we're dealing with the x-axis. X-axis on the inclined, x-axis on the horizontal. That is very, very much important. It's either you can use minus 180 degrees or you can use 0 degrees. What will happen there? You have to think about f of x all the time. F of x all the time. We're not dealing with the f of y here. It's only f of x. It's either your theta is equals to 0 degrees or minus is equals to 0 degrees or theta is equals to 180. Cos 0 is 1. Cos 180 is minus. Okay. Let us carry on. And then I need you to take out your calculators and work out this problem with me. Okay. Which 7,500 minus. I need you to verify your answers with mine while I'm busy doing calculations. That is 120,000 divided by 20 times cos 0 is 1. Then 1 multiplied by 20 is 20. Which is equals to okay. The answer there is equals to 37,500 minus 120,000. You have to divide by 20. That is 7,500 minus 120,000. 1, 2, 3 divided by 20, which is equals to, there is something that 7500 minus 120,000 is minus divided by 20, which is minus 5,625. What are we calculating here? That is a Newton. Okay, this is very, very much important. If the moment you see the minus, we all know that this is a negative work done. There's a lot of energy that has been lost. Okay, We are done with the calculations of this example. All right. If you can just look at this example, this is very, very much important as well. We were busy with the horizontal. This time we have to look at the inclined. When we look at the inclined, what I need you to do, you have to bear this in mind. Make sure that you write down the given information. What are they looking for? What is it given? So that you can just move from given to unknown. If you can look at this, I will try to move fast so that we can move together and do calculations. Because of time, I have to move fast. Okay, we have the mass. That is a square with a mass of 75 kilogram. Sky's down. In other words, we have a slope. The moment you see this, we have a slope. That is the inclined. If you can look at the picture there, it's going down. That is down a slope, experiencing an average frictional force. This is always opposing the motion. It's always opposing the motion of an object. Okay, the slope makes an angle of 30. Now we have been given the angle. The angle there is 30 degrees to the horizontal. Okay, and the square there covers a distance of 30 meters. All right, if you can just look at the distance covered is 30 meters, reaching the bottom of the slope at a speed. In other words, we have the final. If you can just look at this, we have this final velocity. Calculate the initial velocity of the square near the top of the slope. We are looking for initial velocity. We are looking for initial velocity. Let me just take this color. The initial velocity. Okay. All the time, I told you that you have to write down the given information as the data. All right. As the data. We have okay. All right, while we're busy. Okay, thank you. That is the data. This is the data. Given information is very, very much important. I need you to move fast with me. M is equals to what? M is equals to 75 in kilograms. What else? We all know that is down the slope. It's down the slope. It's down the slope. Kilogram there. And then frictional force. We know that we have, frictional force. Is this static or kinetic? That is kinetic, which is equals to, that is 50. That is 50 Newton. This is very, very much important. You must know, is this kinetic or static? But all the time, because the object is in motion, you must know that that is a kinetic friction. It's always opposing the motion. All right. And what else is it given? We have theta. A theta there, which is equals to 30 degrees. That is 30 degrees. And then the distance there, change in x is equals to 30 meters. That is 30 meters. All the time, make sure that you write the units as well while you are busy taking the information, so that you're not going to have some confusion. If I can just write 50 without a unit, you don't know what is that 50 for. What is this 34? Okay, if you can just look at that, we have a velocity. This is the final velocity, V final, which is equals to 20 meters per second. It's 20 meters per second. Okay. We have to, what are they looking for? That is the initial velocity, which is unknown. Okay, thank you very much for being part and parcel of today's lesson. Let us stop here. We shall continue on Wednesday. Thanks.